Hello and welcome back. In the previous session we have learned a few concepts about pixels, colors, images and all. So in this session we will proceed with our first program using the opencv library. And before we proceed we have to install opencv library inside our virtual machine. So this is our virtual machine. I hope you have it up and running. So this was our virtual machine. Let me close this window. We created a folder called opencv and we created a hello world application and we run that application in the last session, and we have also installed Sublime Text, which is our IDE. So everything is ready, but before we proceed we have to install the opencv library. We have installed all the other libraries, all the dependencies that are required to work with opencv, but we didn't install the actual opencv library yet. We can install it using this command. So opencv-python is actually a Python library. Even though opencv is a C-based or CPP based library, it can be combined with any programming language. Here we are using Python based opencv so that we can use it inside our Python program. So we have to use the pip command to install the opencv for Python. So the command is pip3 space install space then the library name. Here the name is opencv-python. Let's do one thing. Let's go to virtual machine, open a command prompt, type the command pip3 install opencv-python. I'm sorry, it's a typo. PINSTALL. Okay, it's downloading the opencv, getting the numpy. So numpy is already installed. So opencv-python is the package which need to be installed. Okay, so here we have successfully installed opencv for Python. Now let's close this command prompt. Now we will open our Sublime Text editor. We are going to create a simple program called fetch display save.py. Any name you can give. I am just giving this name for sake of simplicity. In this program we will be fetching an image from the hard disk, the file system, and we will display the details, everything, the image itself we will display, and we will try to save the image into another format. All these using the opencv library. And the path to the image, that is the file location of the image, is fetched dynamically using a command line argument. So let's see how we can do that. First we need to create a blank file called fetch display save.py. I just opened Sublime Text and let's do one thing. Let's hide this console and all. View hide console. And the console is now hidden. Let's do one thing. Let's save this file at first. Save. We are going to save it to our opencv folder, which is inside our home directory. We have opencv. The file name we discussed was fetch display save.py. Click on save and we have the Python file, which is a blank file inside our Sublime Text editor. And now for all the exercises there are some common line of code that we need to write. That will be shared. That will be common for all the exercises, all the programs. So in this exercise, in our first exercise, we will deal with what exactly these lines means inside the program and why we are using these lines. So the first two lines will be to import the libraries. We are importing a library called argparse and we are also importing library called cv2. cv2 is actually our opencv library, and argparse is used to parse the argument. As I said before, we are going to give the path to the image using command line. The argument that we are passing into the program should be parsed. And for parsing this argument, we are using a library called argparse. So we are going to import these two libraries. So these two lines are the first two lines of our program. Import argparse and import cv2. Import argparse and import cv2. Make sure you are saving it once in a while, just in case. Control S. And now here comes the second set of lines, and these lines are used to get the argument. For example, this is an argument parser object, and For example, in this line, we are creating an argument parser called AP, and here we are adding an argument called image to the parser. And in the second step, we are creating an argument parser called AP, and the argument type is integer because we are fetching the file path, and just we are defining a help text like path to image or something like that. And the argument is actually required. So whenever we run this application without the argument, it should generate an error. And in the third line, we are getting these arguments and saving it into a dictionary called args. So let's go once again. We are creating an argument parser and we are adding an argument called image, and that is a required argument. That is, whenever you run this application, you should provide an image path, and once the image path is retrieved, it will be saved inside this args dictionary. So let's write these three lines. These are the common lines actually we use in the coming. So these are the common lines. We will be using it repetitively again and again. So we will keep it saved somewhere else so that we can copy and paste it every time we run a new program. And here we're going to type ap equal to arg parse dot argument parser and ap dot add argument. Here it's an integer, then the argument name is image and the argument is required. So in Python, it's a strictly indented language. The indentation should be very carefully maintained. If you are just having a tab here, and it will not work, because in Python mostly indentation will be dealing with the level of code. For example, if you are using a for loop, and inside the for loop if there's another loop, so all these things will be defined by the level of indentation which we are using to separate it. Unlike other programming languages where we can use braces or brackets, here we are using indents. So make sure you are not leaving any unwanted indentation inside the code, or if you are using tab for indentation, make sure you are using tab always. And if you are using space, make sure you are using space. Please do not combine the space or tab frequently. I recommend using space itself. And one more parameter to be passed inside the add argument function, which is our help text. This is an optional. Just if you want it, you can have it. And our path to the image. Now we will fetch the argument which the user passes labeled as image. So we are going to fetch it and save it to a dictionary. So args. Dictionary is something like an array where we can store sequential data. Just for the sake of storage, I am using it. Args equal to vars. So we are creating an argument parser. We are adding an argument which is a file path. The argument label is image. Then required is true, and this is a help text. And we are saving that argument into a dictionary called args. So our second step is over, and in the third step we are reading the image from the provided path. For example, user provided the path here, so we have the path. For example, it's a home, my images, then something.png, then that path will be here, and we are passing that path into the imread function, which is actually an opencv function, and this imread will convert the image into numpy arrays. So we have the converted numpy arrayed image into this variable, that is this image object, and now we can easily get the attributes of this image object using shape of 1, which is actually the width, then shape 0 of this image, which is actually the height, then shape 2 of this image, which is actually the channel. If in case of a color image, it's 3-channeled, red, green and blue. So these kind of manipulations were made easy because we have converted the image into a numpy array. So, and we can read the values of the array, the corresponding values. For example, for width, it's a shape of 1, then height it's shape of 0, and shape of 2 for channels. So when you read the corresponding, the respective values, we can get the properties of the image, and we can also use this numpy array to make manipulations to the image. We can convert it, we can edit it. So the first step is made easy by converting the user provided path into a numpy array based image. So let's let's type these lines also. Image equal to cv2 dot emRead args. This is our argument image, that is a path. Then we are printing width image, and we are appending the width value from the numpy array dot format. Format is actually a function used to, just like typecasting, we are converting the integer value into a format which we can display along with this string. So it will be displayed like, for example, if the width is some 100 pixel, then width of the image in pixels is format, then image dot shape of 1. So this is our first print statement. We can copy this statement and use it once again. Copy, paste and paste. So this is a height. The image will be 0, and then channels of the image present in the image, okay, is shape of 2. So we have till here, we are printing the images width, height and number of channels from the numpy array.